Hey guys, we are on Unit 7 and this is day 6 and our warm-up says to solve, and anytime we have a fraction equal to a fraction, we are allowed to do something called cross multiplication. All right, so we're going to have this cross equal to this cross. All right, and when we multiply, it would be 2 times x plus 1. So you're going to have to make sure you distribute, okay? Equal to our other cross, which would be 4 times x plus 3. All right, I like to write it like that first, and then we will distribute, and we get 2x plus 2 equal to 4x plus 12. Okay, we'll subtract 2x, and we end up with 2 equaling 2x plus 12, and we'll subtract 12, and we'll end up with negative 10 equal to 2x, and we'll divide by 2, and x comes out to equal negative 5. Okay, and so there is our answer. And why our answer works is because if we replace our x with negative 5, our top of our fraction becomes negative 2 over 2 equal to, on the other side, if we replace x with negative 5, we get a negative 4 divided by 4. And so this side would give us negative 1, the other side would give us negative 1, and it all works out. All right, so that's cross multiplication, and that's our warm-up today, because when we have similar figures and one of their sides is missing, okay, we can set up what they call fraction equal to a fraction, okay, or a proportion, and we can cross multiply and solve for the missing side. Okay, all right, so here we go. Similar figures. Have the same shape, but not necessarily the same size. Okay? Remember that similar figures have to have all of their corresponding angles congruent. Okay? Remember, angles don't change. Angles stay the same. Okay? Whatever they are in the original figure and their measurement is going to be the same in their newly dilated or similar figure. Okay? Remember that all of the lengths of the corresponding sides, okay, the ratios of them are equal. Okay, that's when we set up those fractions and we test them. Okay, they could call it ratio of similitude, okay, constant of proportionality, or our scale factor. We prefer scale factor. That's usually the wording we go with. Okay, remember that means all sides have been multiplied by the same number. Okay, remember that if you cannot figure out the scale factor, okay, or the ratio of similitude, remember it's that your new length divided by your original length. Okay? Remember, scale factor is what we multiply by, and if we can't figure out what we're multiplying by, we divide. Just remember that it's the new on top divided by the old or the original on the bottom. Okay? So in number 1, they're asking, are the following figures similar? Okay? So we're going to go through and we're going to look at them. And in the first picture, these look like maybe rectangles. Okay? They have all 4 right angles in there, so I would say that those are rectangles. And we have some lengths here. Okay? And if we want to see if these are similar, then our fractions, remember, have to be equal. All right, so all the angles are already the same. So we'll go ahead and compare small side here, which is 2, to small side here, which is 5. And we'll compare large side here, which is 9, to large side here, which is 9. Okay? And so we'll go ahead and set them up. We'll say 2 over 5 should equal 9 over 9. And I think that you guys can see that these are not going to be equal, and therefore they are not similar. Okay? All right, in part B, we have triangles. And we're going to go for side similarity and see if all of the sides are in equal ratios. So we'll do the small compared to the small. We'll do our medium compared to our medium. And we'll do our large compared to our large. Okay? And then we'll go ahead and set them up. So we'll go ahead and say 6 over 8. Does that equal 9 over 12? And does that equal 12 over 16? Okay? And if we type them in, all 3 fractions, and hit enter after each one, we're going to realize we get 0.75, 0.75, and 0.75. 0.75 is the same thing as 3/4, so we could do something like this. We could circle our equal signs to show that we checked. Or we could say 3/4 equals 3/4 equals 3/4. Okay? And so these triangles are similar. Okay? By side, side, side similarity. Okay, we learned that on day 4 notes. All right. And then in our last picture, it looks like we have some pentagons. They have 5 sides each. All right. And if we go ahead and compare their sides, since all the angles look like they've already been matched up, okay, we would have, well, I guess then it wouldn't be really too bad to compare because small side here compared to small side here, right? So it basically be comparing 3/5 equal to 3/5 equal to 3/5 5 times, right? And obviously these are all going to come out to be equal. And so, yes, they are similar. All right, we'll hop down to number 2. And in number 2A, they want to know, are all equilateral triangles similar? Okay, so if we draw an equilateral triangle, maybe a small one, and then like a large one, okay, remember that all equilateral triangles angles are 60 degrees, so all the angles would match up. They'd be 360-degree angles in the small one, 360-degree angles in the big one. And remember, all sides are equal. So if we make the side here, let's say like the pentagon up there, if it has all sides of 3 and this one has all sides of 5, and you would end up with 3 equal fractions of 3/5 equal to 3/5 equal to 3/5. And so, yes, these are similar. Okay. Part B, we actually already talked about rectangles up here. Okay. And so we're going to have to say no, not all rectangles are similar. Okay. Part C, circles. Okay. If we had a little circle and a big circle, so there's no angles in circles. In fact, the only measurement in a circle is the radius. Okay. All right, so if we compare the radius of one to the radius of the other, let's say this radius is 3, let's say this radius is 5, we get that 3/5 ratio. And all radii of the same circle are the same. So there is no other measurement. And so what we get to is that, yes, all circles are the same. Not same, similar. Okay, yes, all circles are similar. All right, they have the same shape, just different sizes. All right, same thing with the equilateral triangles, same shape, just different sizes. Okay? Rectangles, though, because they have those 2 dimensions, the length and the width do not have to always be in those equal ratios. All right, and that's why rectangles aren't all similar. All right, number 3. It says that the sides of a quadrilateral are 15, 20, 25, and 30. So if I go ahead and draw a quadrilateral, okay, and show you with a 15, a 20, a 25, and a 30. Okay? And we have a similar triangle. Okay? And they're saying that the shortest side of the similar triangle measures 6. Well, here our shortest size was 15. So this similar quadrilateral is smaller. So if I draw a similar quadrilateral, same shape, different size, okay? And where I put the 15, I will then have to put the 6. Okay? They want you to determine the scale factor. So that's a number that we're multiplying by. So we're wondering 15 times what is 6? Okay. And if you can't think of it because it's not a whole number, then remember what we talked about there. We talked about taking the new side and dividing it by the old side. So our new side is 6. If we divide it by our old side of 15 and we type it in our calculator, we get 0.4, which could be our scale factor. Okay. Or if we math frac it, that's 2/5. Okay. So what's happening is that every one of these sides is getting multiplied by 2/5 or 0.4, whichever one you want to talk about. Okay. So if we take our scale factor and multiply all of our sides by 2/5 or 0.4, okay, then we will get our new side. So 20 times 2/5, that would become the side, which is here 8. Okay. 25 times 2/5 would give us our new side of 10. And 30 times 2/5 would give us our side of 12. Okay. And so now we have all the new sides of our similar quadrilateral. Okay. If they wanted to, they could ask us to find the perimeter of our new one. And therefore, we would just add up our sides, our 4 sides. Okay. All right. So we'll go ahead and try our notes on the back side. I'll see you guys there.